written here. Prove that triangle PQR is similar to triangle TPR and TQP. So we want to prove this similarity. So what do we do? First thing first that we need to do is that we need to communicate when you're writing. Tell us which triangle are you talking about? Where is it coming from? And then going like that and going like that. Okay, so I'm going to start like this. First part that I'm going to start with is that in triangle PQT, I am going to say let angle Q be equal to x. It means that if this angle Q is x, right, it simply means that here, this is 90 degrees here, because this one is 90 degrees, angle is only straight line, which means our T for this one is 90 degrees. And then this angle, this one is going to be 90 minus x. It's going to be 90 minus x. How could we get 90 minus x? We are going to say, let's say for example, but this one is something that everyone knows. If this angle here is 60, definitely we know this one, it becomes 30. But they don't give you like that under grade 12. They like you to think outside the box. So they can say maybe this angle is going to be called what? Theta. If this angle is theta, how much is this one? This one becomes 90 minus theta. So don't forget that part. That's the first part that you must just know. Okay. My next step is going to be like, if by any chance we want to look for, if we are using maybe, let's say, if we say let Q be equals to x, it means that angle P is equals to 90 minus x. And also, we automatically know, if, let's say, for example, if we are going to use a triangle, if we go to triangle PQR, if by any chance if our Q is equals to x, it means that also R is going to be equals to 90 minus x. Why? Because this angle here is 90. So if we have the x here, it means that this one becomes 90 minus x. This question is easily done. And then we also know that QPT, I spoke about that one. And then, so it means that if this one becomes 90 minus x, as I said here, right? It simply also means that this angle here is going to be x. Therefore, we can come back